from Center for Computer Science and Applications, Dibrugarh University. Today, I'll be presenting on file in C programming, a fundamental topic that helps us understand how C manages data permanently using files. Now, let's begin with an introduction to file in C. In programming, data stored in variables exist only while the program is running. Once the program ends, the data is used. To solve this problem, we use files, which allow us to store data permanently on the disk even after the program closes. C provides built-in library functions to create, read, write, and close files easily. Using files not only helps us save and reuse data, but it also makes our program more efficient, practical, and real-world applications, such as managing records, saving reports, or storing user data. Now let's talk about why we use files in C. Number one, we use files in C to store large amount of data permanently, as the volatile memory, that is random access memory, cannot store large amount of data. The data we use in our programs normally wipes out after the termination of the program. Therefore, to store this data permanently, we use files. Number two, to exchange data between programs. To exchange data between programs, we need to store the data elsewhere permanently, and then we can exchange to another program. And number three, to preserve user data for future use. The files helps us preserve the data and prevents rewriting the data again, so that we can use data more efficiently. And number four, to reduce data redundancy and improve efficiency. Files helps us reduce data redundancy by storing the data once and not having to rewrite it again and again, and hence helps improve efficiency by less space taken. In C programming, files are mainly divided into two types: text file and binary files. Let's start with text file. The, the text file stores data in human readable form, for example, .txt file that can be opened in Notepad and any other text editor. Each character, number, or symbol is stored as text, which makes it easy to view or edit manually. On the other hand, binary files store data in a machine-readable format, meaning the data is saved as binary code, which is not directly readable by the humans. However, binary helps faster to process and take up less storage space compared to text files. In short, we use text files when we need readability and binary files when we need speed and compactness. Now let's look at the basic file operations in C. There are four fundamental actions we perform when working with files. First, we create or open a file. This is done using the fopen function, which allows us to specify the file name and the mode, like reading or writing. Second, we read data from the file using functions such as fscanf or fgetS to get the stored information. Third, we write data to the file using functions like fprintf or fputs to get the stored information. Third, we write data to the file using functions like fprintf or fputs to store new information permanently. And finally, we close the file using fclose, which ensures all data is permanently saved and resources are released. These operations together form the foundation of file handling in C programming. In C programming, every file we work with is connected to the file pointer, which is special type of variable declared as a capital FILE asterisk. This pointer keeps track of the file being used and allows the program to perform reading and writing operations. For example, we can declare a file pointer like this file asterisk fp semicolon. To actually open a file, we use fopen brackets function, which takes two arguments, the name of the file and the mode in which we want it to open. For instance, the statement fp is equal to fopen bracket colon data.txt comma the colon read r which stands for read semicolon opens a file named data text in read mode. If the file exists, it opens successfully, and otherwise it may return a null pointer indicating that the file could not be opened. So the file pointer and fopen together are essential for starting any file operations in C. Now let's talk about the different file modes used in C programming. When opening a file using the open function, we must specify a mode which tells the compiler what kind of operation we want to perform. If we need the mode read R, it means the file is open for reading. But remember, the file must already exist. The mode W is used for writing. It creates a new file. It creates a new file if it doesn't exist or overrides an existing one. Now we have A, which stands for appending. It 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 opens the file for writing, but instead of erasing the old data, it adds new information to the end of the file. There are also combined modes like R plus, W plus, and A plus, which allows both reading and writing in a single file. So by choosing the right mode, we can exactly control how the file behaves when open. Now let's see how we actually read and write data in file using C functions. For the function fscanf is used to read formatted data from a file, similarly to how we use scanf for console input. Next we have printf, fprintf, which is used to write formatted data to a file, for example writing strings, comma numbers, or formatted text. Then there are fgetC slash fputC, which are used when we want to read or write a single character at a time. These are useful for handling text files character by character. Finally, fgetC and fputcs are used to read or write entire strings, such as complete lines of text. Each of these functions gives us control over how we handle data, whether we want to process it character by character, line by line, or in a formatted structure. After finishing all our operations with a file, the final and the most important step is to close the file. We use the function fclose for this purpose. For example, let's use fp. Closing a file is very important because it ensures that all data written in the file is properly saved and that no information is lost. It also frees up system resources that are being used while file was open. If we forget to close a file, the program might behave unexpectedly. Sometimes data doesn't get written completely or the file may become corrupted. So remember, whenever you open a file in C, always make sure to close it using fclose. Now Look at a simple example program that writes data to a file using C. First, we include the header file studio.h because it contains all the necessary functions for file handling. Inside the main function, we declare a pointer using file fp. Now next, we open a file using the statement fopen. fopen. Here example text is the name of the file and the mode w means we are opening it for writing. If the file doesn't exist, it will be created automatically. Then we use the fprintf function to write the message hello file handling hello this is file. And finally, we close the file using fclose fp to make sure all the data is saved properly and the file is released from the memory. When this program runs, a new file name example.txt will be created in the working directory and it will contain the text that we wrote. To conclude, file handling is one of the most important concepts in C programming because it allows us to store and manage data permanently. Unlike variables, data in files isn't lost when the program ends. It stays safe for future use. But understanding how to create, open, read, write, and close files, we can make our program more efficient, reliable, and practical. For real-world applications, we have also seen how functions like fopen, fprintf, fcloseup work together to perform these operations safely. In short, mastering file handling gives us the ability to build programs that can handle large datasets, store user information, and create records, which are essential features in modern software. Thank you.